All right, thank you all for attending this webinar where we will talk to you about mastering Galera Cluster best practices as well as new features that may be of interest to you. So as always, as I said, there is a little question and answer area. You can ask questions by typing in the question area, and they will be answered a little later as well. So feel free to ask away. So I also, of course, have a tiny ad because we have training, advanced database administration with Galera Cluster available in both Europe and North American time zones just next week, actually. So highly recommend you to give it a go. So first and foremost, let's talk a little bit about the replication types that are available in your typical MySQL. We of course have what is very commonly utilized by many people, the asynchronous replication, which is the insert, where you have a primary and it writes to either one secondary or two secondaries or three secondaries and so forth. It needs obviously a framework to handle automatic failovers because it doesn't handle failovers and the failback automatically. And you may have secondary lag, but this is very fast because you only have to write to the master or the primary. It doesn't guarantee that it actually ever reaches a secondary server. Now, there's also the semi-synchronous option where you have an insert to a primary and it is guaranteed to reach at least one secondary and to get the transaction, but you still need a framework to handle automatic failovers. And then there is, of course, the virtually synchronous Galera cluster, where when you make an insert, you are actually writing to 3 nodes, but it writes to one node first, and then it certifies the transaction across all the other nodes, and then the transaction gets shipped over, especially if it's a large transaction, which is why we call it virtually synchronous replication. You do not need any framework to operate failovers because all failovers happen automatically, and all nodes will contain the same exact data as well. So it is ideally, generally very useful for you if you have a high availability setup and requirements. What I don't cover, of course, in this talk is the fact that you can also have Raft as a replication methodology only available in the Facebook MySQL tree. And of course, InnoDB cluster, which is virtually synchronous, very similar to Galera cluster, but it is defaulted to be single primary mode, which basically is like having one primary with multiple read backends. Galera replication in its form is the simplest form of replication available out there because it is just a replication plugin for database servers. So in theory, you could plug it into many other database servers because it's just the WS rep plugin, which is the write set replication plugin. And it just uses the replication API to interact with the DBMS. And it is open source, so you can fully get access to it. Galera 3, Galera 4, which is the current version. And of course, the database in the Galera plugin must have the same WSREP API version. So while this talk is not going to be about upgrades, I would be remiss to mention that you should, if you are using Galera 3 and MySQL 5.7 or an older version of MariaDB or Pagoda HDB Cluster 5.7, it is time to upgrade to MySQL 8.0 or PXE 8.0 or a newer version of MariaDB Galera Cluster, which includes Galera 4, because that's where all the new features are at. And MySQL 5.7 is no longer in support, so you should really upgrade. So just as a quick overview, Galera Cluster allows you to read and write to all nodes in the cluster. And I think this is extremely useful overall because it looks like one large database with multiple entry points. It resolves gracefully any potential row level write conflicts. And every transaction, as I said, is processed locally until commit time and replicated across nodes to the entire cluster. And of course, every transaction is immediately replicated. So you don't have a stale secondary. This is the whole idea of a certificate replication. And you, of course, have data consistency protections. You don't have stale data reads, and you don't have unsafe data modifications. So a few important topics that we should probably discuss from a higher level is we describe this as virtually synchronous replication, largely because of the certification that I talked about. It is high availability with no data loss, zero data loss, and consistent data across all nodes. There's no single point of failure because you have a minimum of 3 Galera cluster nodes. If one node goes away, you still have a quorum to continue operating. And that's why we have what is known as quorum-based failure handling. Everything in the Galera world has a vote to it. So voting happens when it comes to transactions, which transaction should be a priority or a victim, for example. Voting happens when nodes go away, when nodes come back. All of this is why we recommend an odd number of nodes. So that I think is one of the best practices. You can run a 2-node Galera cluster, but I do not recommend it. You can run a 4-node Galera cluster, but you don't want to have a situation where you have a split brain situation. If you have a 4-node Galera cluster, be extremely careful because if you have a network partition between 2 nodes and another 2 nodes, effectively both can say that they are active clusters and there is no way to merge data inside of a MySQL database, which is why it is pertinent that you plan your Galera cluster setups very actively. Okay, is the mouse pointer away now? Better? I hope so. And it has what is known as optimistic concurrency control, which basically means a transaction is processed independently in each cluster node. Write sets are of course replicated at commit time before the commit happens, before you get an OK. And then any cluster-wide conflicts gets resolved and the victim will roll back. So this is 100% multi-master. You don't need any frameworks, etc. And it is extremely fast. Galera is truly optimized also for cloud. I mean, I don't know many people today who are not running in some kind of cloud setup or situation. So you may not necessarily use Amazon or you may not necessarily use Google Cloud, but many people are already running cloud related setups or they are using it over a wide area network. And Galera's protocol is optimized for operations in such networks. We also, of course, have topology aware replication. So if you have multiple data centers, each transaction is sent to an elected node in the remote data centers, as opposed to it being sent, say 9 times, it'll be sent 5 times in a 9-node setup. So I actually have an example later for what this actually means for you. And a lot of people run in 3 different data centers, their Galera cluster, and they're generally quite happy with it because it is highly performant again. We can also detect and automatically evict unreliable nodes, and we don't really allow flappy nodes to happen. So if you're having network protocol failure on a regular basis, you are given a timeout and you then have to do a manual intervention when the node comes back. So that is another useful thing. And by default, unless you set to ignore split brain, you will not have any issues with split brain if you set up a 3-node Galera cluster properly. And we support full traffic encryption, which is very important. Just so you know, MySQL replication, async, semi-sync, fully sync, they all replicate in plain text. So SSL is extremely important. Now let's give you some application thoughts. I'm going to presume that many of you are already aware that there are 3 distributions of Galera cluster. There is the one that is provided to you by Coalition, which is the latest, greatest. There is MariaDB Galera cluster that's part of MariaDB server. So it has all the MariaDB features, and that's enabled in your Galera cluster. And MariaDB also gets very up-to-date work because all of the engineering work happens with us and MariaDB. And then, of course, you've got the Percona XtraDB cluster as well, where they do the work independently from us. And obviously, some features may differ. But what doesn't differ is you have to ensure when you use a Galera cluster, all tables have a primary key or a unique key. And the reason why this happens is because when you're doing deletes or cascading deletes, things may go out of order and you may start noticing failure, which is something you're trying to avoid naturally. So primary key is extremely important. Because you're using InnoDB, InnoDB actually has an internal primary key assigned if you don't have a table with primary key, but it is imperative that you don't rely on this inside of InnoDB. And now with the ability to do alter table in an online fashion, it would make more sense for you to ensure that you have tables with primary keys. And for the ones using MariaDB, you can actually force creation of tables only with primary keys. So there are options for you today that will help tremendously, and I highly recommend you to do that. We actually have queries that we utilize to help you find tables without primary keys. And if you find them in your Galera cluster, you should definitely augment and fix that. Of course, you also have to make sure you're using the InnoDB storage engine, which is the default since MySQL 5.5. But some people we notice still have ARIA or MyISAM. Especially if you're on MariaDB, you can experimentally use ARIA or MyISAM for Galera cluster. We don't really recommend you to do this, especially because MyISAM itself is not transactionally aware, but ARIA kind of is. And in MariaDB, by default, temporary table storage is in ARIA for what it is worth. So MyISAM not utilized, but ARIA definitely utilized. So my advice again is if you are using MariaDB, you should consider the temporary table storage engine to also be switched to InnoDB, and just use InnoDB as a whole to basically give you more ease of use, I would say. So if you are on MyISAM, I definitely advise basically a migration to InnoDB. Then you shouldn't use lock tables and unlock tables. We do not recommend this. In fact, we should tell you flat out that it is an unsupported operation so that you do not use things in an incorrect fashion. And then we also do recommend that if you happen to write applications that update the MySQL user table, and just so you know, in MariaDB, it is no longer the MySQL user table. It's called the MySQL global underscore privs table. But MySQL user is what you call a view against MySQL global privs. We do not recommend you to write manually into that, so you do not do an insert or an update into MySQL user. We recommend you to use the create user statement or the alter user statement, because then we trap the DDL and we ensure that it is executed, which is also important. Schema changes. You do rolling schema upgrade, total auto isolation or non-blocking operations, you definitely need to have planning. If you're using any kind of schema upgrade, if you're trying to use schema upgrade tools, etc., you definitely do need a lot of planning in advance, because you have to ensure that it is not causing undue network traffic for yourself, and is also ensuring that the updates happen across all the nodes as well. And then, of course, I have to also caution you about this hot row problem. So if you have a lot of updates on the same row, with the example you're running a queue or you're trying to run a counter, this can definitely be a bit of an issue. So if there are two transactions writing to the same row and committing to separate nodes, you really means only one can successfully commit. So you will get an abort or a deadlock, and you need to retry the transaction. So you can, of course, try the retry auto commit. And here is a quick example of what actually happens in the log files. So here, you can see two factors. We turned on WSREP log conflicts in the my.cnf. And then we noticed there was a conflict between two nodes that tried to execute an update statement on the same row in the same table at the same time. So one node was given priority and the other node was dubbed a victim. As you can see, in the priority transaction number 9, victim transaction number 16. And because we had WSREP log conflicts enabled, we got this well documented inside the log file. However, you'll notice that Galera obviously handled the conflict without any problems. And you just, if this was happening to you, you want to investigate to see how this conflict even occurred, and so that it doesn't happen too often, because you keep on having certification failures and conflicts, you'll actually notice that your database server is not working as fast or as efficiently as it should, right? Now, we actually wrote a very nice article about how you should handle auto increment on our library knowledge base in the documentation. So we're trying very hard to make sure that we give you the best documentation possible, including with how-tos. So highly recommend you to check out that link. So it's a bit of a homework there. These slides, of course, as you know, will be published. Some connectors, for example, connector J has built-in high availability capabilities like load balancing. So inside the connector itself, you can have 3 connect IP strings, and it can actually do things like round robin, load balancing, etc. for you. Otherwise, you just have to write simple scripts for login management, error handling to connect to 3 different nodes. But if you can't change your application, and your application is expecting only one IP address, then it is time to use a load balancer. So we actually ask, do you need to read-write split? And the answer is actually no, right? You never in Galera have to do a read-write split at all. It is an option entirely up to you. If you're finding that you are encountering a lot of hot rows as a problem, if you're finding that you would like to just gain more read performance, not as much as write performance, then you may consider using a load balancer in front of it. And we have load balancers available for you. You can use Galera Load Balancer, which we provide to you completely open source and free. So you can sit on an existing app server, or you can use Proxy SQL, which is GPL-v3. You can also put it on the app server, assign it 1 GB of RAM, for example. And Proxy SQL also comes with Galera Cluster native support, and it also comes with the ability to cluster Proxy SQL as well. So that's another very important, useful feature. Now, I did not on this slide mention MariaDB MaxScale, but MariaDB MaxScale also works with Galera Cluster very well. No issues there. The only caveat is MariaDB MaxScale is not licensed in a free open source manner. It is licensed with what is known as the business source license. So you actually have to pay a license fee to use either MaxScale or the nodes behind the MaxScale. So, but MaxScale is very much like a level 7 proxy, very much like Proxy SQL. So it also has extensive Galera support, including a Galera monitor, and it has the ability to retry transactions. So if Maxtail detects that the Galera node it wrote to does not have um, has gone away, it will from the router itself retry the transaction on another node. So I think that is another useful feature. So why do we go for Galera 4? Besides the fact that MySQL 8 is now the only supported MySQL out there, I do not advise you to use 5.7 for a new deployment any longer. Then we shouldn't even be talking about Galera 3 anymore. We should be only talking about Galera 4. We have many new features, some of which I have some slides for, but I want to talk to you about a few that we don't put slides on for. For one, if you use MySQL or MariaDB, we provide native GTID support. So we follow the GTIDs of the server you have by default. This may seem like a small internal change, but it is extremely useful as an end user. And especially if there are any replication faults, you can always find GTID positions for you. We also, of course, have improved foreign key support around error handling to ensure that your foreign keys are not throwing unnecessary errors into the error log. But foreign key support has always been around. We have something called a clone SST. So if you're doing an SST, you may already be familiar with rsync, extra backup, or Maria backup. And you know, those are the methods. We have scripts for them called WSREP, SST, and method name. Now, we also have something called the clone SST option, only available in Galera Cluster with MySQL 8. And this uses the clone plugin, which is much faster than extra backup and moving stuff over the network, because it's kind of like minimal lock-free rsync of the data directory. So SSTs happen so much faster with clone. In fact, when you use something like Galera Manager to do a deployment, if you use MySQL 8, we will use Clone SST by default. In fact, it has also got better user management. So we recommend Clone SST overall. We also have a few WSREP functions that you can implement inside of your application to show you the last C global transaction ID, last written global transaction ID, and so forth. So that I think is important. And we also have something called XA support. XA transactions are distributed transactions. They've been popularized previously by many Java frameworks, and you can totally use them with Galera 4, except one of those enterprise-only features. So let's talk about ones that are actually like open source. For one, SST donor selection is no longer random. So SST handshake will favor a donor that can perform an incremental state transfer much faster, the segment you're in, the proximity, and you can also force it via the WSREP SST donor option. We turn on primary component recovery by default, and all nodes have this group information in persistent storage on disk. We also have streaming replication, so you can now do a load data in file for anything larger than 2 gigabytes, which is the previous limit. So you shouldn't have any issue now importing data or doing ETL-like operations into your Galera cluster. And transactions are replicated gradually in small fragments during the processing. So before the actual commit, Galera already replicates these fragments. Fragment sizes can be controlled on a per query basis, so you don't actually have to have streaming replication turned on by default. And you can just basically say, I'd like this next transaction, it's going to be big, it's going to be low data info. I'd like it to stream, and I'd like it to chunk in 20,000, every 20,000 rows to have it replicated without any issue. And I think that's extremely useful as an end user. You have poor network connections, and this is, common inside of a WAN or a cloud, Galera is more resilient when it will handle poor network connections. Basically, now we have inconsistency we find to be the worst problem you can face. And Galera basically will verify the interface for inconsistencies, scans the data set for inconsistencies, and if we diagnose it during runtime, emergency shutdown of the node is forced. And if, of course, there's a node failure, it'll trigger a cluster consistency voting protocol, and the cluster will be composed of nodes, and if there are any consistent database contents, we'll avoid a full cluster crash. And we also have something called cluster error voting, where now the protocol for nodes to decide how a cluster will react to problems in replication. So if you have nodes having issues applying incoming transactions, this feature helps. And if you, of course, have a 3-node cluster, we can only have 1 node failure. A 5-node cluster having 2 or 3 node failure is okay. These nodes will get removed. The DBA can come in to go fix what went wrong, and then the nodes can rejoin the cluster. Maybe one of the most exciting features inside the enterprise version of Galera cluster or the Picona HDB cluster is the non-blocking operations, non-blocking DDL, also the enterprise version of MariaDB Galera cluster. It's very similar to total auto isolation for anything like alter table, create index, drop index, optimize table. You set this dynamically on a session basis. This is much more efficient locking. And what we find is that if you have shared hosting environment and you have maybe 100 media wikis on it and they all require an update immediately, having this is extremely useful because you don't lock the entire cluster. You only actually focus on locking that particular database. One of the biggest problems we have seen, generally speaking, in most consulting operations is that people do not, unfortunately, calculate the GCache size. The default GCache size is 128 megabytes, and the larger your GCache, the longer your nodes can remain disconnected from each other while waiting, remain disconnected and still get an incremental state transfer. Your GCache is only 128 megabytes and you have a lot of transactions happening. You will probably hit your limits very quickly, and you always have to get a full SSD. And SSDs are obviously slower than a GCache, than a IST, right? So the GCache configuration, very important. We never tell you to have it at 128 megabytes. We always encourage a much larger GCache. And in the unlikely event that the GCache is somehow corrupt, only then will you get a full SSD as opposed to an IST. So we always recommend you to have incremental state transfer if you can. So this is extremely crucial, is that you should configure the GCache by calculating the GCache size. And the GCache size is actually stored in your options file in your my.cnf. So this is not something you can change at runtime. So if you are thinking of so you should always set this up as a default early on. So make some calculations and come up with the right size, and then you'll know how much downtime you are willing to have. And in this particular example, if you set the GCache size large enough, we can afford about 5 hours worth of downtime, which is probably sufficient if you're in the cloud, maybe not so sufficient if you're running in a data center. All in, sometimes there is failure. If all of your nodes crash and are down for whatever reason, you obviously don't need to restore the nodes from a backup, but you should check the contents of the GRA state file on each node in your data directory, and you can see what it looks like there. Verify that each node has the same value for the UID, and they most likely will, but if they don't agree, it means you have a split brain. If the UIDs are different, then you have a problem. If the UIDs are all the same, then look for the sequence number. because the node with the highest value should be up to date, and then use that as the seed node. If you have more than one node with the same highest value, then you just pick one to be the seed. If I were you, I'd start the database server on that seed node with write-set replication on equals off and add read only. Then you start, make sure your data is all good. If everything looks good, only then do you actually start write-set replication via the bootstrap option, right? So you always have to bootstrap your first node. And you may have to edit gra state.dat to change safe to bootstrap from 0 to 1 and let it start as the seed node. And once that's happened, you should be able to restart the cluster manually if it all went down in terms of failure. It's extremely rare this happens. When it comes to monitoring your cluster, there's many things you should probably focus on. You want to make sure you have integrity when all of the nodes in the cluster receive and replicate write sets from each of all of the nodes. So what we can do is we can compare UIDs. So when all nodes are synchronized with each other, they will have executed all the same transactions. And since they all have a UID, the last UID on each node should be the same. So you can check this via WSF cluster. Counting the nodes is extremely basic. It ensures that you have a minimum of your 3 or 5 nodes or whatever you decide to have. Another approach to checking cluster integrity is to do an audit. So do this via WSF cluster conf ID. This shows the total number of changes that have occurred in the cluster, changes that the node on which it's executed is where. Each node in the cluster should provide the same value. Otherwise, it indicates a partitioned cluster, which is not good. If you have a very high number, it may indicate that the nodes are also dropping and restarting themselves over and over again. And of course, you should ensure primary status with cluster status. So it should always return a value of primary. And if you find that it's non-operational, that's not good. And there's of course the node status. So you check cluster integrity, and also monitor the status of the individual nodes. So we advise you not just to check this stuff out of the cluster, but also on each individual node. See whether the node is receiving and processing transactions from the cluster write sets. If you somehow have WSREP ready set to off, the node will not be ready and queries will fail. We also have the WSREP local state command, which is very easy to understand because by default it should just return a value of synced. But sometimes you will see it doing joining or waiting on SST or joined or synced or a donor. And this happens when Galera is performing its operations. And if you don't like what you see as a value, just run it again, because that can actually change pretty quickly. And then, of course, we love to also measure replication health because when your nodes are very busy, what Galera does is it has something called flow control. And to manage the replication process, you can consider this kind of a bit like what is a slave lag, but not really. This is basically when there are too many write sets in the queue. Galera will pause replication until it gets caught up. This can be reset when you run flush status, but well worth noting. So WSREP local queue average, it shows the average size of the local receive queue since the last status query. Greater than 0 indicates the node can't apply write sets as fast as it's receiving them. So look at the min and max of those values as well. And it's and in addition to doing that, of course, look at how your outgoing connectivity is going as well. So check local send queue average. And if the value is greater than 0, you may notice that you're having replication throttling or network throughput issues. And then, of course, if you see flow control paused, again, you can reset this by running flash status. Anything that is greater than 0 tells you that your replication health may be a little weaker. So I would closely monitor this. I don't know if Peter, you deleted a question you have. I will answer your questions later, but I think your last question seems to have disappeared off the question list. So please type it again. And then you also want to monitor WSREP cert depth distance. It tells you the average distance between the lowest and highest sequence number, which is values a node can potentially apply in parallel. And then this will help you also set your WSREP slave threads or WSREP applier threads in MySQL 8. So there's a bit of a difference there. I always say never ever disable the error log. You really need it. MySQL 8, especially, that's where your password is stored as well. And it's where Galera puts all its information in the MySQL error log. I like turning on WSREP log conflicts equals on, because in records when two nodes attempted to write the same row, the same table at the same time, as I showed in an illustration earlier, you can turn on cert log conflicts in the provider options, which will log certificate failures during replication. Those are two options I tend to keep on. WSREP debug equals on is extremely verbose. So you're going to record everything, potentially even authentication methods. So I would enable that in a production environment, but if you're having a real problem, then definitely take a look at it. And one more tip I'd have for you is what is a log that I didn't put on the slides, but I think it's worth noting is if you look at your MySQL data directory, you may find things with a GRA underscore number and log. And if you see these log files being generated periodically, you should review them, because it shows basically the node was unable to complete a transaction or some other event. You have this special binary log file. You can parse it with MySQL binlog, or you can also parse it with reading it in a text file mostly. Review them. They will differ on each and every node, because transaction conflicts happen typically on a node basis. And if you see something amiss, you should obviously take a look and fix it. Galera supports multiple data centers. So I have always done demos with 9-node Galera cluster between London, Singapore, and San Francisco. And these work a charm, but you must, of course, configure them. So I'm going to give you some configuration tips and tricks. So, when you synchronize nodes over a high latency link, the penalty is incurred at commit time. There are no delays or communication between the remote nodes during the transaction itself. Galera doesn't use distributed locking, so each row level lock does not have to be communicated across data centers. In very high latency situations where you can't avoid, slave lag, asynchronous replication, of course, may be an option for you to set up, each running in its own data center. And yes, you can mix and match Galera and asynchronous replication. So now this is going to be, I guess, quite interesting, because I'm going to give you a lot of tips. Basically, over a WAN, we use segments. So you should segment 0, segment 1, segment 2. So by default, Galera will send all communication, every write set sends to the node, to all other nodes in the cluster. But the behavior can be changed using segments. Segments will allow you to split your Galera cluster into several parts. Each segment may contain multiple nodes, and elect one of them as a relay node. Such nodes receive write sets from other segments and redistribute them across Galera nodes, local nodes to the segment. So you get so you basically are able to send traffic instead of the previous diagram I showed you. You don't have to send traffic 9 times over the network. You're just actually sending it over the WAN 2 times 2 replicas, and one is basically 1 per data center, compared to like a 1 secondary in MySQL application. Things I would pay a lot of attention to: GMcast segment equals 1, 0, 1, 2. The EVS send window and the EVS user send window should be set to about 512. They work well over a WAN. The eviction protocol, that's what EVS stands for. The EVS keep alive period, minimum of 3 seconds, which you write as PT3S, for example. Suspect timeouts, you can do 30 seconds, PT30S. Inactive timeout, typically 1 minute. Install timeout, also 1 minute. Retransmission period, retrans period, 3 seconds. Delayed margin, 3 seconds. Of course, you can see causal read timeout, 5 seconds. So basically, the higher latency allows more in-flight replication at once. So if you increase your timeouts above the cluster's max round trip time, you need to measure this, obviously. And larger timeouts will increase time on failure. So you can use WSREP sync wait, increase that to something like 7. And then you should also consider playing with the flow control limit. So flow control limit at 16 maybe. You don't need to ever do flow control with the master slave. Yes, as an option. I don't think that's a great option, frankly. But you can play around with it. So definitely take a gander. Here's an example of what a configuration looks like, a my.cnf, a very basic my.cnf, with showing you how to actually use the segments. I want to remind you that when you use these WSR provider options, you cannot change them at runtime. So you will have to restart the node, and that's the last thing you want to do in production too often. So plan ahead. We have plenty of other useful tools to think about, and I'm leaving some time for questions and answers naturally, because normally we do this in 45 minutes, but today we'll go a bit longer. I'd say take a look at the Galera arbitrator daemon. If you don't want to run a 3-node Galera cluster, you can effectively run a 2-node Galera cluster with one guard-D. And you can also, use Galera load balancer, which I have talked about earlier. And of course, there's Galera manager. So again, not something I'm talking about, but it is something you should totally take a gander at. Galera manager will handle everything automatically for you in terms of deployment, all monitoring, etc. So I'm going to now answer questions. So of course, yes, yet another ad, and we can use this time to get your Q&A sorted. So let me go to the question and answer thing. So I think so far Peter is the only one who asked questions. First he asked me to move the mouse pointer. So I think we did that. And then the next question is, can we use a chem as a load balancer? Yes, you could use chem. You could use actually many load balancers realistically. Again, for what it's worth, you could use Nginx, you could use Camp, you could use even hardware load balancer if you really wanted to. Maybe the most important thing for you to remember is when you do use these load balancers, ask, is it a level 4 load balancer, which is basically TCP/IP sort of routing, or is it level 7, where it can also understand the proxy, beyond that, it can understand proxy protocol, can it also understand SQL? So proxy SQL and MaxScale understand SQL, which is, if you ask me, a good thing, and they're also fast. So that's why we lean towards you using something like that, but the choice is entirely yours. As a heads up, I cannot tell you either way which one is better, but you are more than welcome to use your own, including HA proxy, by the way. So that's I guess that answers both your questions, Peter Helfer. But you might have had another question, but it disappeared off my screen. So if you want to ask that again, you should. And then we have another question here from Eric. Advice regarding backups, yes. So do you know that with the Galera cluster configured, some people actually run without backups? This is perfectly okay because every node is basically a backup of another node. However, that would be a little dangerous. So we can recommend you to use extra backup for physical backup, or Maria backup for physical backup. So you have to use Maria backup if you're using MariaDB, by the way, and extra backup if you use Galera cluster or Pacona XDB cluster. Now, if you want to use you want to get a logical backup, you should use MySQL dump, obviously, but not from the Galera cluster itself. I would recommend you to have a asynchronous slave or asynchronous secondary and use that. And the reason why I say that is because every time you do a backup, there's elevated I/O. And when you have elevated I/O, this is actually a problem for you for the database server because Galera performs as fast as its slowest node. So here's another tip, of course, and we've seen this at consulting as well, where we find that people don't have the same hardware or the same virtual instances for the Galera cluster. This is, of course, a problem. You must have everything, all the configuration, memory, CPU, etc., must be the same. But during a MySQL dump, especially on a very large database, you will, of course, have elevated I/O, and that's not recommended naturally. So you should, so what we would recommend you to do is, of course, have an asynchronous slave or an asynchronous secondary. There's also the ability for you to use garbd to trigger backups. I don't know how many of you are familiar with the Galera arbitrator daemon, but garbd can also trigger backups, which might be useful for you as well. That is another method we do recommend. And beyond that, we do not recommend you to obviously rsync your data directory or CP your data directory, but garbd can actually use what is known as wsrep desync equals on, and then you turn it back on by wsrep desync equals off. So you actually, what you technically do during this process is you desynchronize the node from the cluster. So it's still a member of the cluster, but it is not at this point accepting writes. You make consistent backup, and then when it comes back as a member, as a write capable member, you get what is known as an incremental state transfer of all the missing transactions during that time, but you're still operating a 3-node Galera cluster. So those are several backup methods that we can recommend for you to use. Hope that answers your question. Yanko asked the question, is the clone SSD method supported on MariaDB or is it only for MySQL? The answer is clone SSD is only for MySQL 8. It doesn't even work on Percona XDB cluster 8. So it's only MySQL 8. So it's what we provide to you, which is good. Is there a similar alternative to speed huge SSDs? Because you have 2 terabyte SSDs taking over 9 hours. Okay, we should probably talk offline as to why you're having this issue. What kind of, I don't know what kind of network you have. Because 2 terabyte over a fast network should be pretty good. Because if you are doing 2 terabytes of data transfer over a reasonable network, it shouldn't take that long. And it sounds like it's trying to do an ISD first before it is doing an SSD. And I can only tell you that from the logs, if we get to see it. But yeah, two terabytes over your usual, say even a 10 gig network should definitely not take that long. If you ask me. So even over a 1 gig network, it should not take that long. So definitely something to figure out. Okay. Nicholas says my dumper does a good job too. Yes, there's work on my dumper still. And there's also been work around parallelizing my dumper. So we have another question. Is ZFS snapshots a valid backup method? The answer is not really. So FYI, there is something even for LVM backups, LVM snapshots of my LVM backup. There's also ZFS snapshots that you can trigger. And we are okay with you doing backups like that, but we don't guarantee them to be like a logical or physical backup. And it is naturally something that is also involving particular version of Linux, and every time a kernel makes a change, you could have an issue. We have had a customer, not on FreeBSD ZFS, but on Ubuntu ZFS, have an issue in the past. It had something to do with ZFS itself having issues in the kernel update. So yeah, we don't really say that the snapshots are a super valid method. They work. They should work most of the time, but yeah. And then the other one, if you're going to ask, is ButterFS, and we don't think that's ideal either. Yeah. Okay. So 2 times 10 gigabyte local network. That is too that's way too slow. So please ping me afterwards to help you. Okay. And the email address is there to help you for what it's worth. We have another question. Yes, 2 comments. How So it's actually a priority and victim transaction is the crux of your question. So if you noticed earlier, gotta get this playback. So the question is, when you have multi-threaded applications doing read and at the same time asynchronous, so we will ensure that you don't read something that has been not committed to all the nodes yet. So we follow read permitted, and we actually put that in the we have a nice isolation levels document that tells you that in multi-master mode you should be on repeatable read as your level. So not read uncommitted, not read committed, but repeatable read. So we are on repeatable read um, by default. So we don't want you to have any phantom reads. And if you have a priority or a victim transaction, as I said, until it certifies on the other nodes, you will not have said issue. Ooh. We are using snapshot of disk in GCP with Galera Cluster. Yes, of course, it definitely does work. GCP snapshots work, and on EBS snapshots work as well. If you want point-in-time recovery, we of course recommend extra backup, right? Turn on your binary log. It also helps. In fact, turning on your binary log is probably always a good idea. So I don't know what you're using on GCP. Are you using MySQL, like Percona XDB cluster, or Maria? But if you're looking for Galera point in time, you should probably look into these options that I'm giving you, basically. So we definitely do support point in time recovery. So turn on your binary logs. So log bin and bin log format equals row, of course. And then again, MariaDB backup or extra backup supports point in time recovery. Plus you have the ability to have this in your binary log file position. So you don't need the binary log for you to succeed in a Galera deployment because we use a GCache, but you should definitely have the binary log turned on if you're looking for point in time, because you have the ability to do a start position, stop position, and so forth. In fact, if you tell me you're using MariaDB, I can also tell you that we have something called binary log flashback, which you can use MariaDB bitlog, and also there is a GTID point in time recovery. So many cool ways for you to do it, depending on the database server you're using. So I can only give you, we are using Galera with MariaDB on Kubernetes. So yeah, so use Maria Backup. Again, I don't know which version you're using, but I can tell you that if you have bitlog, you can do point-in-time recovery via Maria Backup and use MariaDB bitlog to get the start and stop position. Or you can use flashback. So it's MariaDB bitlog -- flashback. You can give a start position and a stop position. And there's also -- GTID with strict mode, where you can actually start and stop with GTID positions. So good that you're using MariaDB and you have your plus bitlogs on GCP. So you already actually have point-in-time recovery and you have flashback. The GTID variant, I think, only comes with 10.8 and greater. So if you're using something like 10.6, which is a long-term support release, then worth noting that it'll come soon. Any easy way of migrating without any downtime specific database instead of all databases to a different cluster? Well, is there an easy way of migrating without downtime? There's some databases. Well, you can of course dump some databases by itself, but if you are looking for selectively migrating some databases, no downtime, my suggestion is to use asynchronous replica and turn on replication filtering. So you actually just filter what you want, and then once you've got that, you provision a new Galera cluster, for example, from there, and that could work for you. I think that mostly should be the easiest way for you, Yanko. Okay, 10.6 moving to 10.11. Okay, so 10.6 doesn't have the GTID, but 10.11 definitely does. But you already have definitely got the binlog. You also have access to flashback. Flashback came around in 10.2. So you are actually golden there for what it is worth. So we've had some very good questions here. And some interesting use cases. I highly recommend you to check out the ability to send email to me, especially Yanko has 2 TB plus SSD taking over nine hours. When I guess you're also running MariaDB possibly, which is why you asked, does it work with MariaDB? And yeah, if you are, that's a bit of an unfortunate bit that we don't do the clone SSD, but MariaDB itself doesn't support clone plugin. There's been requirements for it, but it hasn't happened yet. Yeah. All right, so I think that more or less wraps up Q&A session. You can obviously send email over to me and I will respond to you. So I'd like to say thank you very much for listening. Thank you for asking good questions. And yeah, happy Galera clustering. If you have more questions, send email. Thank you, everybody.